So now we're going to show you how to find volume by water displacement. We're going to need a graduated cylinder, which I have here, 100 milliliter variety. I've already filled it to the 60 milliliter mark. So that is my initial volume. So I'm going to fill this right in here, initial volume, 60 milliliters. Now I take my object that I want to find the volume of. Notice it's an irregular shape. You're not going to measure length times width times height than this. Easiest way, drop it in, slide it in gently. Make sure no water pops out. And record the final volume. Make sure to get eye level, read the meniscus. The final volume is 67 milliliters. So, the volume of the object that displaced the amount of water is 7 milliliters. My object, the rod that I've dropped in there, has a volume of 7 milliliters.
Alright, so like Mr. Muir showed us, now you guys are going to have a chance to practice with a paper lab. You're going to find volume by water displacement looking at a bunch of different graduated cylinders. For this first example here, well, Mr. Muir's graduated cylinder had increments of 1 milliliter. But when we're using different types of graduated cylinders, we need to check the increments. So on this first one here, I see that there are 1, 2, 3, 4, 5 divisions, and my first marking shows me 5 milliliters. So that tells me that every tick mark is 1 milliliter. What I'm going to do then is I'm going to read my final and initial volume. For my final volume, I see that meniscus, and it's lined up right at the 10, 11, 12, 13, 14. Final volume of 14 milliliters. My initial volume, and it might be difficult to see on the video, but I can see my line for the water is halfway between the 4 milliliter and the 5 milliliter mark. So I have initial volume of 4.5 milliliters, and then as Mr. Muir showed us, we do some subtraction to get our displaced volume, and our final volume of the object is that displaced volume. Because we're talking about a solid, we can use units of centimeters cubed. When we're talking about liquids, we use milliliters. Those two units are equivalent. Alright, so now we're going to do one that's a little more complicated. This is off of that worksheet, so if you're watching the video, you can jump to number 13 here. Well, for number 13, I see that my increments can't be 1 milliliter because I see that that first major tick mark is 1 milliliter. That first tick mark is broken into 1, 2, 3, 4, 5 minor tick marks. So I have 1 milliliter broken up into 5 pieces. Each one of those is 1/5 of a milliliter. Well, we are 8th graders and we're scared of fractions. In this case here, it makes more sense to turn that into a decimal. Each tick mark is exactly 0.2 milliliters. 0.2, 0.4, 0.6, 0.8, 1 milliliter. Each tick mark has an increment of 0.2 milliliters. Now I'm going to do the same process I did before. I'm going to take my final volume minus my initial. My final volume is sitting right at that 3 milliliter mark. Makes it nice and easy. My initial volume is 1 tick mark above the 1. But I know that each tick mark is 0.2 milliliters, so my initial volume is 1.2 milliliters. Now I need to do some subtraction to find out my displaced volume is 1.8 milliliters, which gives me an object volume of 1.8 centimeters cubed. My units when I'm talking about solids are centimeters cubed. My liquid volume is milliliters.
And your job today now is to finish up the worksheet. That's all she wrote, folks.